Have you ever wondered why our planet isn't a frozen, lifeless ball of ice, or why, despite its vastness, our climate seems to be changing at an alarming and accelerating pace? It's a question that delves into the very core of Earth's complex systems. Today, we're cutting through the noise to explore the undeniable science behind climate change, unraveling the mechanisms that govern our planet's temperature and how human activities are significantly altering them. Get ready to understand the how and why of the most critical environmental challenge of our time. Our journey begins with a fundamental concept, the greenhouse effect. Think of Earth as having a natural, life-sustaining blanket in its atmosphere. Certain gases, like carbon dioxide, methane, and water vapor, trap some of the sun's heat that radiates back from Earth's surface, preventing it from escaping entirely into space. This natural process is absolutely crucial. Without it, our planet's average temperature would be a frigid -18 degrees Celsius, making life as we know it impossible. It's what keeps our planet comfortably warm and habitable, much like a greenhouse keeps plants warm, even in cooler outdoor temperatures. The problem arises when we, through various human activities, start making this natural blanket thicker and thicker. For centuries, the concentration of these greenhouse gases in the atmosphere remained relatively stable. However, with the advent of the Industrial Revolution, our reliance on burning fossil fuels, coal, oil, and natural gas, for energy began releasing massive amounts of stored carbon dioxide into the atmosphere. Deforestation further exacerbates this by removing trees, which naturally absorb CO2, meaning less carbon is taken out of the air. Industrial agriculture and landfills also contribute significant amounts of methane and nitrous oxide, potent greenhouse gases. We're essentially turning up the thermostat, intensifying a natural process far beyond its natural equilibrium. The evidence for this human-induced warming is not just theoretical, it's tangible and overwhelming. Scientific observations confirm a clear upward trend in global average temperatures, with the last decade being the hottest on record. We see it in the rapid melting of glaciers and polar ice caps, contributing to a measurable rise in global sea levels. Satellite data confirms the dramatic retreat of Arctic sea ice and the thinning of ice sheets in Greenland and Antarctica. Furthermore, our oceans, which absorb a significant portion of atmospheric CO2, are becoming more acidic, threatening marine ecosystems. Ice core samples provide a historical perspective, revealing that current atmospheric CO2 levels are higher than they've been in at least 800,000 years, far exceeding natural fluctuations. It's important to differentiate between weather and climate. While a cold snap doesn't disprove global warming, long-term trends undeniably show a hotter, more extreme planet. The overwhelming scientific consensus, as documented by intergovernmental bodies like the IPCC, points to human activities as the primary driver of observed climate change since the mid-20th century. Sophisticated climate models, validated by historical data, project a future with more frequent and intense heat waves, altered precipitation patterns, and increasing instances of extreme weather events, impacting everything from food security to public health. Understanding this science is the first step toward informed decisions and effective solutions. So, the science is clear: climate change is a complex, yet well-understood phenomenon, driven predominantly by human emissions of greenhouse gases, and its impacts are already being felt globally. The evidence is robust, spanning multiple disciplines, and supported by a vast body of research. If you found this deep dive into the science of climate change insightful, please give this video a thumbs up, subscribe for more science deep dives, and share your thoughts and questions in the comments below. Let's keep the conversation going.